Hello everyone, welcome back to my channel and I'm back with some new learning tutorial on LTSPICE for you all guys. Today we're gonna see the Monte Carlo simulation on LTSPICE, how you will do it and how it is done. We're gonna see it precisely. So let's begin our tutorial without no delay. This is the window you can see of LTSPICE. I've already built it as circuit, but I'm gonna explain each and every component to you one by one. So this is the circuit. So we are checking a Monte Carlo for inverter circuit. So this is the driver and this is the load. And what is Monte Carlo first of all? Monte Carlo is varying a more than two variables at the same time. So that is not done by any other command, but Monte Carlo is a process for at the same time and running on a number of cycles, more than one number of cycles. So let's see, let's learn and dive here with a simple example how you can do that. So this is the circuit of inverter you must be aware of. So you will take one PMOS at the VDD and one NMOS at the ground. VGS, that is the input voltage assigned over here with the name of the voltage V3, and the RLC parasitics of this interconnect, and C is working as a load. So R1 is your resistance, L1 is your inductor, C1 is your capacitance, and how we are varying a variables over here for V2, R1, L1, C1. So the command that is for Monte Carlo is MC. So how it is done? What is this command means? I'll explain you right now. So MC and 5 is the value of the VDD I am giving, and tall is the variable by the amount of which I am varying this variable. Okay, then here coming at the resistor, MC is the command for Monte Carlo, 141 is the value, and tall is the variable by the amount of which I am varying the resistance. And here again 2 nanohenry is the value of this L1, and tall is the variable I am by the amount I am varying this inductor value. And same is the case with capacitance. 1 picofarad is the value, mean value, and tolerance is the variation of this value of capacitance. So how the tall value is defined? Coming here, so dot param is the command you use to vary this variable tall. So that is I am equaling it with 0.05. It is a 5 percentage of tolerance value plus or minus, and I am assigning one dummy variable to the Monte Carlo cycle, that how many number of times it will run. So I'm assigning it as X, then starting at a 0th cycle to 100 cycle, and the steps I'm taking as 1. And I'm doing transient analysis with the 50 nanoseconds. And here is the VGS. Let's see what I'm assigning here. So at the initial value I'm assigning 0. I'm switching on this with at 5, and a delay of 8 nanosecond is given. Rise time is 5 nanosecond, fall time is 5 nanosecond, and on time and off time is 20 nanosecond, and for the period of 60 nanoseconds. Click OK. Fine. So the Monte Carlo thing is clear. Then you need a technology file to run this inverter. Either you can directly include this text file from the Google, you will get easily include 180 nanometer of text file, or either you can directly write these commands and define the width and length of your transistor as per your convenience. I have given the values of transistors as a symmetric value, and they are as such. So let's run and see what happens. So I'm running it, click on the run button. closing this window. Okay, just we'll check it simultaneously. That's why I'm not closing this window. Bit down is fine. Okay. So here I'm at the input end. I'll check the my pulse. Okay. So this is the pulse I'm getting at the input end. Let's see, zoom in. This is the multiple lines we are getting. Zoom to fit in because the see because the input is the same. So for different values we are getting. Now at the output we'll check. Okay. Okay. So now you can see this is your output. I'll maximize it. You can see this is your output values you are getting for the inverter for the variation of R, L, C and VDD at the same time for the 100 number of cycles, and that is your Monte Carlo simulation. Fine. From here further we can calculate the delay and power for the cycle. Fine. Or and either you can take this data out also. So that things we will learn in the next tutorial. Okay, this must be a good learning for you to build an extension of complex circuits and do a Monte Carlo simulation. So, if you like this content, please like the video, share with your friends, do subscribe the channel for more such technical and complex content and new content, and also practice it well. Without practice you can't get through it, so it is a must. Either channel you use from the contents available on your social media, but you have to practice and keep learning, that will make you ease with the tool. Fine. And thank you very much.